the features in the settings is capturing a file and determining what path that you want to save an image. And this is really important from an efficiency standpoint, since SpecFinder is also a computer system and it has a wireless card involved with it, and it can also be hardwired. This can tie directly into your server. And so an operator, a supervisor can set up a default path for images to be saved onto a server. So right here is where I can define the directory path to store my images. So there's a little dialog box to the right, and that opens up the computer. And so if I wanted to save that either on my local hard drive or on my network, I can do that. And so every time the operator or other user captures an image, the file will save to that directory that has been defined. And that's important if there's a multi-workstation environment where there may be 4 or 5 or 10 different operators working on different shifts, so that they don't have to retrieve an image from a camera or rename an image. There's actually a way to automatically name an image, which is right down here in the image naming convention. If you have a production lot, for example, that you would like to name the images that are captured for that particular production run. So let's say if I have production run ABC 1, 2, 3, then every time the operator clicks an image, it will store that base name or that production lot in our example, and then index it by whatever factor I determine, so that the operator simply has to capture the image and it will be saved. It can also be saved in different file type formats, in a BMP image, a JPEG, or a TIFF file format. Or if I would like the image to be renamed after capture, and that causes a lot of efficiency. It allows the user to rename the image without having to reopen the image after it's already captured. So every time we can save a step, every time that we can allow some automation in the process to occur, we're increasing the efficiency of the entire process. Also on the movie files, if you are going to be taking a video, the same thing applies here. You can name provide a base name here and then index it or rename it after the image is captured, but before it's actually saved to the file location that you define. So here we're going to rename the image after we take the capture. So I'm going to hit capture, and I'll have a dialog box appear. It's going to save to the default path that I defined. And so if I want to name this, I see chip, I can go ahead and name that right now. And that way it will be named prior to it actually being saved to that directory location. Okay, so after you take an image, then you can actually preview the image that you've taken by hitting the F2 function, and that will call up an image previewer, and you can just double click on the image and you're pulling up the image that's saved to your default path. So the F2 function is useful for that purpose. Also, we're going to go into the settings menu, and we're going to go down to the top choice, which is the video device. And there is a video codec option, and there are a number of different codecs that are available for compression when you actually take a video, and we recommend using the video encoder. It gives you the best balance of image quality along with compression. And so, for example, if you take let's say a 15-second video or a 30-second video, that's going to be about 40 megabytes worth of data. If you did not use a compression program or a video codec, it would be about 40 times that big. So that's going to be important if storage space is at a premium and something you want to minimize to your server, or when exchanging a video file either internally or with a customer. So going into the video device under settings, choosing the video codec or the DV video encoder will allow you to compress the file into the optimum size. One of the very powerful features of SpecFinder is the standard orbital ring light that's included with it. And what's powerful about it is in video microscopy, it's very important to be able to control glare and reflection, because when you're looking at a specular surface and you have top-down illumination and the light bounces off of the reflective surface and it transfers back up through the optic and hits the sensor, it can have a lot of glare and it's very distracting. Normally, an operator would have to pick up the board and adjust it or maneuver it, or in the case where we have our orbital table, they can maneuver the object this way. But another way to control glare is through our ring light, which is a patented ring light by Dazor. And we can open up the software and then open up the actual image at the same time. And through control of the software that's integrated with the mouse, we can actually dim down both rows of ring lights, and there's 40 LED ring lights, or 40 LEDs in each row of the ring lights. I can disable either row of the ring light, and those are 6500 Kelvin white ring lights. And I can also control the directionality of the illumination, and that's important when you're looking at solder joints or these legs, for example. And if I want to create shadowing or control glare, I can do that simply by adjusting the mouse on this slide ruler. Now, I can also, just by turning my rotation wheel on the mouse, I can also perform that same function. The directionality can be reduced all the way down to a single LED if I'd like to do that. And then there is also, if I want symmetry across the ring light, I have a mirror function, and then I have different, on this slide bar, I can control the pattern and the number of the LEDs that are illuminated. So in this bottom section of the directionality slide rule, I have symmetry directly across, so I split the LEDs in half, and then by positioning this slide ruler, I can increase or decrease the number of LEDs. And then if I click over in the direction control, and then just by rotating the wheel of my mouse, I can rotate that pattern of LEDs. And you can see on the live image how I am controlling the actual glare off of the surfaces and highlighting different components. When I change the slide ruler up into the next quadrants, I get a tri-directional LED, and then the pattern continues to shift as I move the slide rule up, and then I can, again, with the direction control, come down and with my mouse or in the slide rule, just rotate the LEDs. So this LED ring light, again, this particular ring light has white LEDs. We also have a system that has UV LEDs, either the inner row or outer row of LEDs with UVA, so it's 365 nanometer, either on the inner or outer row. And then we also have a dual row UV LED, and that's important for inspection of conformal coatings. So the LED ring light is a very powerful tool that can be used in conjunction with the SpecFinder system, and it's a way to integrate the lighting directly with the SpecFinder and allow the user maximum control without having to pick up and touch the object or rotate the object.